Today I have the pleasure to introduce Professor Yanfang Yao from Shanghai Jiao Tong University. Professor Yao has visited us for almost 4 weeks, mainly in the frame of our joint master program, Language and Communication Technology. He was also so kind that he agreed to tell us a little bit more about what they do in the joint research laboratory they have in the Shanghai Jiao Tong University, together with the University of Saarland in Saarbrücken. So the talk will be about opinion mining, and I hope you'll enjoy it.
Thank you. Good afternoon, everybody. First of all, I would like to thank Professor Coburn to invite me to give this talk. So this research work is financially supported by the NSFC, that is the Natural Science Foundation of China, including the text annotation, preprocessing, and text classification, and also the recognition of topic and analysis of the sentiment, and also the relationship between the topic and the sentiment identification. And also this work is, was accomplished in the joint research work, joint research lab. So I would like briefly introduce the joint research lab. So this lab is established by the Department of the Computational Linguistics and Physics in Saarland University, and also our department. So it is established on the March 2005. It's located at the department of our department. So this building is our school. Our department is located in this building. So this room is for this joint research lab. So this is organization and staffing. So this is our honor to invite Professor Uskreut, who can be as German head of this lab. We have the several principal researchers, and also the PhD and the master students. So for mission of the lab, we want to apply the projects not only from China, but also maybe the other Germany and otherwise. And also we want to shorten the path between the lab result and market. So we have also applied several projects from the industry. So this is the direction of our lab. One is the language and technology research, and also the web mining application, Chinese information processing, and the information service. So for this later three, I think is for industry. The company have the interest for the such as the information service and web mining. So here list several projects. These two from the NSFC, and other from the industry. For example, this is the data mining, and other is the information retrieval, and so on. So today, my talk focuses on this research work. It's on opinion, the fine-grained opinion for Chinese texts. So in this work, we should do the classification for subjective text and objective text, because we need the opinion, the subjective text. And then we should do several subtasks for the preprocessing, for informal words recognition, and also the text classification. And then is the topic recognition and sentiment analysis and relationship identification. First of all, I do the investigate for the subject text type and subject sentence type. For example, for the subject text type, we get information about the standardization domain and amount of the text available. For example, this is a different standard for the subject text on web. And also domain, for example, single domain or multiple domains. Also for the amount of the text available. So we have the interest for this part of the subjective text before we can get more such text, and also the version is the electronic version. So we have the interest in this text and for our research work. So this is the several conclusion for the investigation. For example, which text we need and which content difficulty and so on. And also for the subject sentence type, we find that there are different relationship between the topic and the sentiment. For example, one-to-one, one-to-many, many-to-one, and many-to-many. So in our work, we do the one-to-one and one-to-many. We focus on these two sentence topic and sentiment relationship. And also we find that the relationship between the topic and the sentiment may be explicit and explicit, on explicit, implicit, and so on. We could focus on when is the explicit and explicit. And also we try our best to do the research for the implicit topic and explicit sentiment. So in order to do the supervised learning, so we do the annotation by ourselves. For the text set, we use the existing work. For example, this is the parcel for Chinese parcel. We use the tag, also dependency tags from this. We also use the national standard part of speech tag. And for opinion elements, these tags are defined by ourselves. So this is the opinion elements tags in the different levels. This document level, sentence level, and a sub-sentence level, and the word level. Here I would like to explain is one is the claim. Claim means here the sentence has the sentiment part. We say this sentence is a claim. So if we can determine the claim, then we can do the opinion mining in this sentence. Otherwise, possibility to fit this sentence. So this is the claim. And also for the holder, this is opinion holder. So we want to know this opinion is who gives this opinion. So this is the holder. This tag for the report maybe is important. From one report, maybe the several opinion holders. Also for the word, we have the two word type. One is the sentiment word, the other is the general word. So here, giving an example, very simple two clauses. One is that I don't like this car. The second is that the price is too high. So we use the green indicates this is the topic. But this topic is in the different level. We say the car is the topic, the price is the subtopic. So we use maybe the ontology to check the topic in different levels. And also we use the red color to indicate the sentiment word or sentiment part. For example, this is the verb, this is the adverb. So we focus maybe two word class. One is the verb, noun, adjective, and adverb. So this is the example for annotation for just the example. So this is the first clause. In this annotation, we annotate for example, holder and relation. Relation, this is the holder and topic. And also we include all words in the sentiment part. For example, this sentiment part is composed of the two words. One is this English is do not. The other is the like. So we combine these two words together as the one sentiment part. So this sentiment part is the negation. Also here is a topic. This is the second clause with a topic and sentiment. We also group these two words, to and high. This means the expensive. So in general, some sentimental words are depend on the context. For example, the high. Here, the high means the price. So we say this high is the negative. But sometimes maybe this high is the positive. So this depending on the context. In order to improve the quality of annotation, we students developed an annotation tool. So in this annotation tool, we accomplish several steps. For example, the claim segmentation, word segmentation, we use another existing tool, and word annotation and opinion element annotation. So this is the one of the interface for this tool. So we can use mouse very easy to put several words together. For example, we want to put these two words together as one sentiment. So we can put these two words together. And also sometimes we can change some tag and so on. So this is the tool to help us to annotate the word, the sentence, and so on. Then after the annotation, then we can use this system automatically transform into the XML format. Then we can use this format very easy to access with the corpus and so on. Then we also built small size corpus. This corpus only for our experiment, so very small size. But we can do the statistics and also the retrieval use this corpus. For example, here is do the statistics. We want to count the number for the sentimental word and also the frequency. For example, the first word frequency is the 16, and in 5 files occurs this word and so on. So this for the statistics. We can also use this corpus for the retrieval and so on. Then, if we process the subject text, we find that sometimes there are the informal language words. So such words, if we cannot identify that maybe for the understanding the whole sentence, maybe there's the problem. So we try to identify such words. For example, here there is the several example. Sometimes someone wants to use the alphabetic to represent the normal words. For example, here's the girlfriend, use the GF. Or sometimes use the digit for the normal words and so on. And also we find that another type is someone wants to use the formal word. For example, he or she wants to use the bamboo to represent the web moderator. So for such case, maybe it's difficult to recognize. Also here, the nodes are for the fence and so on. So we divided the words, informal words, into two types. One is we call the typical informal Chinese word, and another is a fuzzy informal Chinese word. The first word means they use the different, maybe the letter, number, and other form combined to represent a formal word. Second is they use the formal word to represent also a formal word. But in this case, the first formal word with the not the original meaning is the different meaning. We say this different meaning is the informal word meaning. So the second word is difficult to recognize. So we use the first, we use the sequential covering algorithm to recognize the first type word. That means the typical informal Chinese word. The performance is about 36%. This is the first. The size is about 5,791 sentences. Test set is the 3,722 sentences. And for the second type, we use two classification mode. Is the naive mode base and also the SVM. So we use the different features for these two modes. For example, the typical NIL words, and also the opinion words, and suggestion words, and the first and second person, and so on. So compare the different feature combination, we find that the last one, that means the identical near words plus the first and second person, and plus the irregular punctuation. This combination is better. And also we find the SVM performance is better than the naive Bayes. So this is for the second type. And then we want to distinguish the different text. One is the subject text, the other is the object text. So we need the subject text to the opinion mining. So this is the purpose to this classification and task. So we use the classification approach. Is also we use the several modes to compare the performance. Here is the rule-based SVM and naive-based mode. And also we synchronize the result according to the weight of the text. Here the weight of text means if the feature more, then we give the high weight score. So this is the weight of the text. Then the feature used for the rule-based and also the SVM classification model. The knife-based classification model used the unigram feature. So here is the different features for the rule-based and SVM. For example, the pronoun or suggestion word, especially for the verb, and also the NRL words, because this word is for subjective text, and also the punctuation, special punctuation. We find that in general, the accurate digit is for the objective text. Non-accurate digit is for the subject text. Also the sentimental word and so on. Then we participated the opinion analysis evaluation conference in 2008. This is the first time do this evaluation. Then organizer gave the nearly 40,000 text do the subjective and objective classification. But they wanted only 4,000 subject text. That means this 4,000 subject text with maximum confidence. Then for our method is, at first we used rule-based classification mode to assign the weight score. Just we say according to the number of the features, then we give the weight. And then we use the SVM and also the other classification mode to do the classification. Here is the SVM, the 8,000 and 21,000 for the objective test. Also, we use the naive-based classification mode to get a different result. And then we combine the different result. That means from each result, we get only the 40 texts put together. Then we remove the redundant text. The remain is about 6,000. Then we put this 6,000 to use rule-based to get final 4,000 text with the higher weight, or we say the maximum confidence. Then this evaluation conference allow us to submit the 3 results. Then we do the first result. The method is just I mentioned. And then the first result, we only use the rule-based method for the 4,000. And the last result similar to the first method, but we added the punishment for the long text because the long text can increase the weight score than the short text. We want to balance these 2 texts. This is the final evaluation result. So I want to clear here the different evaluation. Further, our accuracy 10, accuracy 1,000, that means get the different number from the result, 50, 100, 10, and 1,000. This is evaluated by a human. And also evaluated by a lexicon. This is automatically do. So for our result, the first part is maybe the best, but for the second automatically evaluated is not so good. The reason maybe this lexicon we developed is different from the evaluation lexicon. So this is the difference cause the performance is not so good. Then this is, we compare the other organization, totally 13 organizations participate in this evaluation. So where 3 result is in 1, 2, and 6 position. And then we should consider how to recognize the topics. Here the topics means that maybe we say the product name, maybe the attribute, and so on. So there are 2 ways. One is the domain specific. The other is the multiple domain or the open domain. So here we do the research for 2 types. One is the specific domain. That means based on the automobile domain. The other is the multiple domain. So for the domain specific, we use our just annotated corpus. Then we analyze the lexicon and also the syntactic dependency. And then we also use the relation between the semantic words and the topics and also the ontology to recognize the potential topics. That means this part topic may be missing for the first step. But here we can get more topics for the final result. So this is the performance. You can see if we use only the semantic analyze, then we get the record and processing maybe nearly 80%. Then we add the sentiment word. That means we use the sentiment and the topic relation to find more topics. Then the performance can be improved from 80% to maybe the 85 for recall, and from 74 to 80%. So about 6% can be improved. So this is the domain-specific recognition. Second task is the multiple domain. So here we get the corpus is from the car, laptop, mobile phone, and the digital camera. So we use the SVM classification model and part of speech and also the word sense ambiguity. This is the feature used for this SVM model. And use this conference give us this training data and 5 the cross validation to train this data for SVM model. And for the SW features, we organize the different combination. For example, here the 3 combinations. That means from the coarse grain to fine grain feature combination. Then we can look at the 4 domains. Then we do the experiment for the first basement is only a part of speech. The second basement is a part of speech plus word, the second basement. And for the different feature combination for word sense ambiguity. Then we find if we use the baseline 2 plus the WSD3, that means the finest feature combination, then we can get the best performance for every domain. So also we find for different domains, we get the performance also different. Maybe for car and laptop, the performance is better than the mobile phone and the digital camera. Then the reason may be for the mobile phone domain and the digital camera domain, there are more technical terms. So maybe this is the reason the performance is different. The next task is for the sentiment words and the sentiment word sentiment and the sentence sentiment analysis. So for this part, we not only determine the sentiment word, but also we want to determine the polarity. For example, positive, negative, or neutral. So we also use the Chinese parser to do the parsing for the sentence, and then we use the verb, adjective, adverb, and noun. So these words have the sentiment, we say, these words, and also the idioms. Then we check whether there is the dependency relation in this parsing tree between the constituents relative to the above the word class. So for example, verb and the noun, there is the dependency relation or not, or maybe the adjective and noun and so on. And also we find the topics. We can, with the help of the sentiment, to find these topics because maybe there is a relationship. Then we can use this relationship from the sentiment words to find these topics. If there exists the sentiment word in the sentiment lexicon, then we can easy to determine the polarity. If cannot find such word, then maybe we do this. This work cannot determine, but later we can give this tag for positive, negative, or neutral. Also, this task we participated this COAE 2008. For this evaluation conference task 1, this identification of the Chinese sentiment word. For this task, the result for our team is not so good. So you can see here, totally 11 organizations. But for the task 2, that means analysis of polarity for Chinese sentiment word. Our guest the best result. The reason is for this task we used a different way to do the fine analysis for the word, so we can get the best result. Also for the sentence, we do the sentiment analysis. We use the different mode to compare SVM, maxima entropy, and CRF to classify the sentiment of the sentence. We use the two group of the features. One we call this the internal features. That means a lexicon feature and a part of speech feature. We also use the external features, dependency feature and the context feature. Then we put these two groups in a feature template. Then combine for the SVM, ME, and CRF. So for the domain, we use one is the automobile reviews, the other is the mobile phone reviews, and also the mixed reviews. So The performance for the automobile reviews is about 87%. For the mobile phone, it's the 74%. For the mixture, is the 76%. So compare the automobile and the mobile phone. Also, the automobile text, the performance is better than the mobile phone. So we say in compare these three classification model. The CIF classification model is better than the other two classification model. The last task is about the relationship between the topic and the sentiment identification. We say the fine-grained opinion mining. So this task is the we say the special task for the fine-grained opinion mining. If we can know the relation between the topic and the sentiment, then we can determine which topic is mapped to the which sentiment. Because just I say in the sentence, maybe the relationship is many to many. So this is a very important task for the fine-grained opinion mining. So here we define two types of the relations. One is the direct relation, the other is the indirect relation. For direct relation, there are two types. One is these two, this topic and the sentiment in one sentence or the clause. The second is not in the same clause, but we can determine the relation between these two, depending on the conjunction. That means these two sentences or clauses are the coordinate clauses. The second type is the indirect relations. That means the topic and the sentiment exist in the different clauses. And also, there are no direct modifier relations. So we can use the, sometimes we say maybe the relation is the implicit topic and the explicit sentiment. So later I introduce how to recognize the implicit topic and explicit sentiment. So we say this is the indirect relation. Then we also do a statistic in our annotation corpus. Just we mentioned that these direct relation and indirect relation, total the proportion about 96%. 96%. So that means if we can recognize these two type of the relations, maybe we can improve the performance for the relation recognition. So for the first type of the relation, because this task, this research work is independent of the just the ways I introduced the topic recognition and so on. So in this research work, do the topic extraction and sentiment extraction with very easy method. So the student focus on the relation extraction. So in the relation extraction, they extract at first they extracted all pairs of the topic and the sentiment as the candidate set, and then use two modes to recognize. One is the close distance matching mode. We say CDMM. The other is the SVM mode. For the first mode, we according to the rule to find the corresponding topic. For example, maybe it's the words, maybe it's the phrases. And then if the distance is the shortest distance, then we can extract this relation. For the sentimental word, the topic is not found. It is matched by long distance mode across the punctuations until the backtrack to the last topics. Then we only suppose they are matched. And then if we not find the corresponding sentiment word for any topic, then give it up. So this is the first method. The second is use the different features to do the classification. One is the lexicon feature. For example, topic word, sentiment word, or left word of the topic and the sentiment, and so on. And also the part of speech features. We consider the part of speech for the different word and maybe the phrases. And also the sentiment feature for the topic words. For example, product name or the product attribute and so on. And also the position features. That means the position of the topic word and the position of the sentiment word and so on. For the experiment, we divided two parts. One is for the direct relation experiment. So we use 220 texts, totally 1,500 sentences. There are 4 domains. So each domain about 55 texts. So we use the 200 texts for the training corpus used for, and then 20 texts for the test corpus. So in training corpus, we use the we annotated 1,200 positive relations and 1,600 negative relations. Then first experiment, we want to compare the different scale of the annotated positive or negative relations in training set. So we use the 2 different modes. One is the positive relation 800, negative relation 1,600. Mode 2 is the positive relation is 1,200 and the negative relation is 1,600. So we compare the different scales. Then we find that if we use the more positive examples, that means we do the balance for positive and negative cases, then the performance is better. This is the first experiment. The second experiment we want to compare for the relation identification for different domains. For example, we use the SVM and the Model 2 for different domains. There are 4 domains. Get the performance is different. We find for laptop and mobile phone, the performance is better than the automobile and the digital camera. So that means the performance for the relation identification from the different domains different. So maybe the reason is the number of the technical terms, just we mentioned, is different. Then the third experiment, we want to compare the different classification mode. That means CDMM and SVM mode for one of the domains. Here is the digital camera domain. So the result is we find the SVM mode is superior to the CDMM model. So the SVM is the best is the 71, and CDMM the best is the 60%. Then for the indirect relation identification, I give you an example here. So you find that there are 4 clauses. The first clause, there are 2 topic, 1 sentiment. And the last one you find looks beautiful here, only sentiment without topic. Then we say this clause is an implicit topic and explicit sentiment. So the question is how to find the implicit topic. Then we utilize the ontology to find whether here there is the relationship between the IT means the implicit topic and the main topic. If we find that there is the relationship here, then the second step is we find there is the collocation, the implicit topic and sentiment here, SR, the sentiment. If we find that there is also a collocation relationship, then that means here there is a relationship, but this relationship is the, we say the implicit relationship. The direction relationship is this sentiment and the main topic is the main topic. So this is the idea to recognize an indirect relation. So just as we say, we can use the ontology. It means if we find the concept and the sub-concept, for example, here maybe the car and the appearance, then we know the car and appearance, there is a relationship between the concept, there is the relationship. Then if we find the beautiful and the appearance, there is the collocation relationship. That maybe there is an implicit or the indirect relation. Indirect relation. So we can say the appearance and the beautiful, there is a relationship. So this is the idea how to recognize. So this is the algorithm for this. So especially it's here, if we find in ontology, there is an up-top concept with the current concept, there is a relationship. Then we can add the relation between the main topic and the current sentiment, and also the potential collocation. So this is the algorithm. So for the experiment for this indirect relation identification, we use the corpus is we labeled by ourselves as 1,000 sentences with on the car domain. And also in this corpus there are 1,400 direct relations and more than 200 indirect relations. We also use the COA 2008 task-free corpus. This corpus is from, there are 4 domains. Then from this corpus, we can get more than 6,000 correct and disambiguity opinion element relations. Then use this corpus, we do the experiment. For the collocation, we use the Google and Baidu is the Chinese search engine put together to collect more than 7,000 collocation pairs. So this is the resource. And also we define the 2 basement for use the different, for example, closed pair method, dependency parsing method, and so a maxima entrancy method to do the experiment. For the three basements, we compare our method. Our method is 82%. Is better than the three basements. And also we compare the different domain, the performance, and also get the average performance is about 78%. Then this is the, we say the domain system. We can show the different steps for the opinion tasks. The first step is the word segmentation. Sometimes in this step, maybe make mistakes. Then we can use the mouse to resegment the words. That means we can correct the result for the first step. And for the second step is the part of speech tagging. This step also we can change the part of speech tag because we want to check the next step. When the input is correct, then what is the performance for the next step? Then the next step is the topic and the sentiment identification. The last step is the relation identification. So this is the demo system interface. So this is the, just I introduced the different subtasks in opinion mining. So we say this task is a very challenging task. So until now, many universities and institutes in China still do this research. So I think this year is the 7th evaluation conference. We participated in the first year and the second year. And then we say the opinion subject test and object test classification are also important preprocessing task for the follow-up processing step. And also we do the fine-grained annotation approach in order to can do the further research for fine-grained opinion task. For the classification and the network informal language, that means if we can, for the preprocessing do the better, then maybe we can improve the performance for later tasks. And also we say we try to the different domain. One is the domain specific, one is the domain independent corpus for the topic identification. And also we use the different mode for the sentiment analysis. For the relation extraction, we use the direct and the indirect for the direct and indirect relation identification. So we can improve the performance for the whole task. And also we developed a demo system to give the different sentence demo. And also we participated in this evaluation conference and get advantageous evaluation results. That's all for my talk. Thank you for your listening.
problem with Chinese homonyms, where actually the difference is only in the tone in the pronunciation? Do you use some lexicon of pronunciation to detect such?
You mean the word segmentation?
I think the example was with bamboo and web moderator. Yeah. So do you have some pronunciation dictionary which?
No pronunciation. We collect many different contexts and so on for the word.
But as far as I know, new like these kinds of homonyms can be invented each day. So
for the new informal words, maybe there is the problem because for this. For this task, the problem is the corpus, for example, such corpus is very difficult to correct because not all the, for example, forum and PBS, there is such case. So we use the search engine to find the different cases. And then we collect the context for this word. Otherwise, it's difficult to say this bamboo is a real bamboo or this bamboo is the web moderator, and so on.
Okay, thank you.
So the second task, I think, is difficult than the first task.
Yeah, maybe my question is naive, but when I looked at the results which you've presented for the different domains, so the naive idea is that between smartphones and laptops there should not probably be such a big difference, but the numbers were different. So is there any explanation for the difference?
Yeah, I think this is also the problem. That means one word maybe can be used in a different domain. So I think this case can be resolved only depending on the context. Otherwise, like just I said, it's high. Why this high is the positive is not negative. So we depending on this topic. So if this topic is, we say the quality, or so this is the positive. If otherwise, maybe there is not negative. So for that, you just mentioned that this word is the meaning. I think at first we should determine this text is from which domain. And then maybe we can, depending on the context, to determine this meaning, I think. Otherwise, it's difficult if we don't know the domain, which domain. It's difficult to resolve such a problem.
Thank you. So, more questions? If not, then thank you again. Very nice talk.